Determine for the function f of x equals 4 over x squared plus 1 for x is less than negative 2, x cubed plus 3x squared plus x for x is greater than or equal to negative 2 and less than 1, and 4x squared plus 2x minus 1 for x is greater than 1. In each of the x coordinates, x equals negative 2 and x equals 1, whether it is parts A through D. Each of the parts involves the continuity and the differentiability of the function, and we're looking at two different x coordinates here. The continuity at the x coordinate of negative 2 requires the two-sided limit as x approaches negative 2 of f of x equals f of negative 2. And the continuity at x equals 1 requires the limit as x approaches 1 from both sides of f of x has to equal f of 1. Let's start with the x-coordinate of negative 2. And let's look at the two-sided limit as x approaches negative 2 of f of x. Now, f of x is a split expression function that happens to split right at the x-coordinate of negative 2, so we will have to work out each side of the two-sided limit separately. So we will have the left-sided limit of negative 2 and the right-sided limit of negative 2. The left side of negative 2 means less than negative 2, so we will be making use of this for our expression, 4 over x squared plus 1. We can now plug a negative 2 in for each of the x's. That'll give us 4 over negative 2 squared plus 1. Negative 2 squared is a 4, and 4 over 4 is a 1, so we have 1 plus 1, and that'll come out to a 2. For the right side of negative 2, which is greater than negative 2, we'll have this expression. So we can replace f of x with x cubed plus 3x squared plus x. And we can now plug a negative 2 in for each of the x's. That'll give us negative 2 cubed plus 3 times negative 2 squared plus a negative 2. Negative 2 cubed is going to equal to a negative 8. 3 times negative 2 squared, negative 2 squared will be a 4, times a 3 will be a positive 12. And then plus or minus 2 is the same thing as minus 2. Negative 8 plus 12 is 4, minus 2 is a 2. So we do have the left side and the right side limits matching each other. We also need to check f of negative 2. And f of negative 2 is evaluated where negative 2 is included, and that'll be here. And so that will give us negative 2 cubed plus 3 times negative 2 squared plus negative 2, which is the same as the right-sided limit of negative 2, and so this will also come out to a value of 2. So we have the left side limit, the right side limit match, and it matches f of negative 2, all three of them match, and therefore it is continuous at negative 2. Let's look at the x-coordinate of 1, and we are looking at the two-sided limit. Once again, it's going to be a split expression function that is splitting at the x-coordinate of 1, so we will have to work out the left side and right side limits separately from each other. So for the left side limit, we're less than 1. We will use this expression, x cubed plus 3x squared plus x. We can plug a 1 in, that'll give us 1 cubed plus 3 times 1 squared plus 1. 1 cubed is a 1. 1 squared is a 1 times a 3. And plus one more 1. And that totals up to be a 5. Let's look at the right side limit at 1. the right side limit of 1 is greater than 1, we will use this expression for f of x. 4x squared plus 2x minus 1. We can plug a 1 in for each of the x's. 4 times 1 squared plus 2 times 1 minus 1. 4 times 1 squared is a 4. 2 times 1 is a 2. And then minus 1. 4 plus 2 is a 6, and then minus 1 will be a 5. So we have the two one-sided limits do match each other. We also need to check f of 1. And f of 1 is evaluated wherever x includes a 1. But if you look here, x never includes a 1. It's less than 1, it's greater than 1, but we never see it equal to 1. And that means that f of 1 simply does not exist. Since it does not exist, there's no way it equals to the two-sided limit, which is a 5 since those match. And so we are not continuous. For the x-coordinate of 1. Once we're not continuous, there's no way we're differentiable there either. So we can tell for this situation at the x-coordinate of 1, we have the limit as x approaches 1 from the left of f of x does match the limit as x approaches 1 from the right of f of x, but neither of these equal to f of 1, which is the exact situation that we call a removable discontinuity. So for the x-coordinate of 1, we have situation D. We have the removable discontinuous, and therefore not differentiable. You have to be continuous to have a chance of being differentiable. So the x-coordinate of 1 give us that situation. Now let's look at the differentiability, because we did find it to be continuous at the x-coordinate of -2, and so we will want to see if it's differentiable there. And differentiability is the continuity of the derivative. Before we take the derivative for the split expression function up here, let's rewrite that first expression as 4x to the -2 plus 1 to help us take the derivative using the power rule. So f prime of x will be, that first term will be our power rule. Bring down that -2. That'll give us -8x to the -3, which can immediately be rewritten as -8 over x cubed. And this is going to hold true for that same interval of x's less than -2. The next expression, x cubed plus 3x squared plus x, will have a derivative that will be 3x squared plus 6x plus 1. And it will hold true for the interval of greater than -2. We do not know yet if it can include -2. That's part of being differentiable there. And then less than 1. And then the last expression will have the derivative of 4x squared plus 2x minus 1, and that'll be 8x plus 2. And that'll hold true for x is greater than 1. We're now going to look at the differentiability, which is only possible at -2. We know it's not possible at 1 since 1 wasn't continuous. So we will just look at the differentiability or the continuity of the derivative at the x-coordinate of -2. And just like the continuity, you have the two-sided limit as x approaches -2 from both sides of f prime of x has to equal f prime of -2. Once again, the split expression function does change over at -2, so we will have to separate into the left side of -2 of f prime of x and the right side of -2 of f prime of x. Let's start with the left side limit of -2. The left side of -2 means less than -2, and we will make use of that expression. -8 over x cubed. The next thing to do is try plugging a -2 in for each of the x's, so that'll be -8 over -2 cubed. So we have -8 over -2 cubed is -2 times -2, which is a +4, times one more -2, which will give a -8. -8 over -8 is a +1. We will now look at the right side limit at -2 of f prime of x. The right side limit of -2 means that we're greater than -2, and we will use this expression here for f prime of x. That'll be 3x squared plus 6x plus 1. We can now try plugging a -2 in for each of the x's. That'll give us 3 times -2 squared plus 6 times -2 plus 1. 3 times -2 squared is a 4. 6 times -2 is a -12 plus 1. 3 times 4 is a 12, and -12 plus 1 will be a -11. 12 minus 11 is a 1. And the last thing we need to check here, the two-sided limits do match each other, but we need to make sure it also matches f prime of -2. And that will be using the expression where -2 was included for f of x. Back up here, -2 is included for this middle expression, so we want to see if we use that middle expression there, if we do get that same value of 1. And so if we plug in the -2 into the middle expression, we'll have 3 times -2 squared plus 6 times -2 plus 1, which is the exact result we had just gotten from the right side limit of -2 for f prime of x. So this once again does come out to a 1. And so we have the derivative at -2 matches the limit of each side of -2. And that makes it differentiable, and that means up here we can take this interval and put the equal sign on the -2, and it also means we have the exact situation of being continuous at the x-coordinate of -2 as well as being differentiable at the x-coordinate of -2. We have situation A, and we have it being continuous and differentiable at the x-coordinate equals to -2.